Okay, on the right-hand side of the same handout, we'll take a look at some of these problems just to get you started. So in number 7, it says, given that the measure of angle A, so I have A, B, C. C is my right angle. The measure of angle A is 27 degrees. And little b is 1, so the side opposite b is 1. It says find little c. Well, it's referring to the hypotenuse. So I need to find the length of c. Well, to do that, I have the adjacent, and I'm looking for the hypotenuse. So adjacent and hypotenuse means I need to use cosine. So the cosine of 27 is equal to 1 over my hypotenuse c. So I'm going to multiply both sides by c. This gives me c times the cosine of 27 equals 1. And then I'm going to divide both sides by the cosine of 27. And so c is equal to 1 divided by the cosine of 27. And I'll let my calculator do all of that work. And c is approximately equal to 1.12 if I round off to 2 decimal places as indicated. In number 9, here I have A, B, C. Here's my 90-degree angle. And the measure of angle B is 60 degrees. And C is 11. Find the measure of A. Well, if you recall from Monday with our special right triangles, the 30, 60, 90s, then I know that little a is going to be 11 times the square root of 3 over 2. Now, if you don't remember them, then you can always use the trig function. So from here, I have the adjacent side and the hypotenuse. So I'm going to use cosine again. So I have the cosine of 60 is equal to a over 11. And so from here, I know that a is equal to 11 times the cosine of 60. So 11 times the cosine of 60 is going to give me 5.5. Oh, because a is my short leg. So here is 5.5 for my a, which makes sense because this would have been the 30-degree angle instead of the 60-degree angle. So this side would be 11 square root of 3 over 2, which would be 5.5 times square root of 3, if I had paid attention to the angle measurements. Yeah. For 11, we have A, B, C. Here's my right angle. So they tell me that A is 7 and C is 25. Find the measure of angle B. So I'm looking for this angle. So again, adjacent, hypotenuse. So I have the cosine of theta is equal to 7 over 25. And since I'm solving for theta, I'm going to use the inverse cosine of 7 over 25. So theta is approximately equal to 73.74 degrees. For number 13, we have given the measure of angle A. So we have A, B, C. C is my right angle. Angle A is 47 degrees. We know that our hypotenuse is 3. Find little a. So I have the opposite side in the hypotenuse. So same setup, but we're going to use sine of 47 instead of cosine. And a is equal to 3 times the sine of 47. And this is going to be a is equal to 2.19, approximately. And number 15 is a very typical right triangle trig kind of problem. It says a ladder leaning against a house makes an angle of 30 degrees with the ground. So here's my 30-degree angle. The foot of the ladder is 7 feet from the foot of the house. So from this point to this point is 7 feet. How long is the ladder? So you're looking for how long that ladder is. So we're going to work with, this is technically our long side. But what we're going to do is we have adjacent, we're looking for hypotenuse. So we have the cosine of 30 is equal to 7 over my hypotenuse. We'll call it x. And now we solve for x. So I know that x is going to be equal to 7 divided by the cosine of 30. And this is going to give me 8.08. So the ladder is about 8 feet.